All right, so last time we looked at surface areas of cylinders and cones. Okay? And if you remember your general formula, take the area of the base, double it, and then add the perimeter times the height. Okay? Well, we're going to come up with another general formula for these as well. So we'll start by looking at surface area of pyramids. All right, so pyramids and cones are pretty much the same basic idea, okay, as I just told you. If you take a pyramid and make the base a circle, now you have a cone. All right, so a lot of the formulas kind of have some overlap here. All right, so pyramid, first of all, it's a polyhedron, meaning all the faces are polygons, and it's a 3D shape. And all the lateral faces are triangles. Okay, when we had a prism, does anybody remember what all the lateral faces were for a prism? Yeah, they're all rectangles. Okay, no matter what the shape of your base is, pentagons, octagons, if you connect all the sides, you're going to have strips of rectangles. Okay? Well, with a pyramid, you've got triangles, and all the triangles meet at a common vertex. Right? That's like the peak or the top of the pyramid. Okay, where two of the lateral faces come together, in other words, two of the sides of the pyramid, that forms a lateral edge. Okay, so in a pyramid, the only edges that aren't lateral are the ones along the base. Those are base edges. Okay. And how many base edges are there? Well, it depends on what the shape of the base is. In a pyramid, the shape of the base can be any polygon. It could be an octagon, so you can have an octagonal prism. Could be kind of a standard pyramid. You could have kind of the standard pyramid where the base is a square, and then you've got four triangles coming up from each side. That's how most people picture a pyramid. But there's many different kinds of pyramids. Okay, so that I just said. Base edges, those are the ones where the base, they run along the base. Okay, and now when we talk about the height, we've got to be careful with a pyramid. With a cylinder or prism, that's pretty straightforward. The height is the distance between the bases. When you're measuring the height of a pyramid, it's the distance between the base and the vertex when you measure it perpendicular. Okay? It's not the distance going up the side of the pyramid. Okay? So if you imagine a pyramid with like stairs on it you could walk up, that's not the height. That's the height at an angle, which has a different name. But the height is basically, if there was a hole in the top of the pyramid and you were standing there and you dropped something and it fell down to the middle, how far that thing fell, that's the height, straight down. Okay, so here's a picture of a pyramid. In this case, anybody tell me what shape does the base look like? Yeah, it's a pentagon, so this is a pentagonal prism. It's got 5 lateral faces. All the lateral faces are triangles. Okay. Common point is the vertex. All the edges coming down from the vertex, those are your lateral edges. The edges that make up the pentagon base, those are your base edges. Okay. And that's the altitude. Straight down from the vertex to the base. Does anybody know the name of that distance if you were to measure it up the side? Yeah?
Slope height.
Close. It's something height. It does begin with an S, so very close. Slant height. Yep. And on your MCAS reference sheet, you might have seen like a cursive L. I think that's how they usually represent it. All right. So a regular pyramid. Okay. Again, it's the kind of pyramid most people picture. Square base. That's a regular pyramid. Anyone remember, what does that mean? It says a regular pyramid has a regular polygon for the base. But if you don't remember what a regular polygon is, that definition doesn't really help. What's a regular polygon? Yeah?
Equal angles and equal sides.
Yeah, it's a polygon where all the sides and all the angles are equal. Okay, so any of these shapes, well, these are all your regular polygons. Different numbers of sides. All the sides are congruent. All the angles are congruent. Okay, any question on that? So a regular pyramid has a regular polygon for the base, and the height meets right at the center. Okay. This one, the height, I think if you drew it straight down, it wouldn't come right in the middle of the base. Okay. This pyramid is almost kind of oblique, right? It's kind of tilting to one side a little bit. Okay, and as I asked somebody earlier, the slant height, okay, that's basically the height if you had stairs on the side of the pyramid and you walked up it, how much of a distance that would be. Could also look at it as the altitude of a lateral face. Okay. Just take one of these triangular faces, okay, off the side and measure the height of that triangular face. Okay. That's the altitude going up the side of the height going up the side of the pyramid. Okay, when we have non-regular pyramids, we don't have a slant height. Okay, so that picture up above, not the best picture to illustrate it, but you can kind of visualize it. Okay, so there's a regular pyramid, square base. Height goes right down in the middle. Slant height goes up the side. What would happen if you connected right there to right there? Okay, think three-dimensionally. What kind of shape would you have? One side would be the slant height, another side would be the height, and another side would be, if I drew this in. Be as specific as you can. Yep?
A right triangle.
Yeah, you'd have a right triangle. This would be, of course, it's perspective. It doesn't look like a 90-degree angle, but that would be a 90-degree angle. If you cut the pyramid and looked at its cross-section, you'd basically be looking at something just like that. That's that triangle I just drew. So if they give us, let's say they give us the distance from the edge to the center. They say it's like 5 feet. And they say you have a slant height in the pyramid that's 50 feet. Find the height of the pyramid. It's really a Pythagorean theorem problem. Right? Really Pythagorean theorem. So once we learn the formula for the surface area of a pyramid, you got to be careful whether it uses slant height or height. And if you don't have the right one, we're going to use Pythagorean theorem to find it. Okay. All right, so what we'll do, we'll start off, just see if we can find the area of a lateral face. And then there might be a shortcut if we wanted to use a formula to do this faster. Okay, but this one says the lateral faces of a pyramid are covered with panels. Okay, use the diagram of the arena below to find the area of each lateral face. All right, so we've got a base here. Okay, it's a regular base, so each side is 300 feet. Okay, the height of this pyramid is 321 feet. Okay, I've marked the slant height on the side. And we want to find the area of each lateral face. Okay, notice they don't say the total lateral surface area. Just find the area of one side. Okay. All right, if we look at this pyramid, Alyssa, each lateral face is what shape? Triangle. Okay, so first thing we're going to need is area of a triangle. Okay, what's my formula for the area of a triangle? Well, James?
Base times height.
Close. Base times height, that'd be for a length times width, would be like a rectangle. Half, yep, good. So it's 1/2 base times height. Okay, let's draw one of the sides of this pyramid separate. Okay, so let's just draw this. Okay, what side do I know there?
300 feet.
Yep, that's the base. So I know that.
You know the height.
The height, do I know the height? Like right here? That's the height that I need. Do I have that?
Yes.
So this height is given to me in the problem.
Yeah, 321 feet.
Is that the height of a side, though, or is that the
No,
height of the
that's-
pyramid?
We're looking for the slant height.
We're looking for the slant height, right. Okay, the slant height is the height of one of the sides. Okay? This height is the height of the pyramid if you were standing at the top and dropped something and it fell straight down to the middle. All right? That's not the height of the side of the pyramid,
Well,
though.
then you take half of 300, you get 150, and then you do Pythagorean Theorem for 350.
Yeah, so let's look at the triangle we're going to work with. There's our triangle. Okay, as Luke just said, if your height comes right down to the middle of the floor, well, from the middle to the edge must be 150 feet because the whole thing is 300. Okay, so that side is 150. So put 150. And the height of that triangle inside here is 321. Now we use the Pythagorean Theorem, and then we can get our slant height, which is going to be that height right there. Any questions on how we set that up? Okay. Can anyone tell me, plugging into the Pythagorean Theorem, how these numbers fit in? What do I do? Yep.
A squared plus b squared equals c squared.
Sure, go ahead.
321 squared
Yep.
plus 150 squared equals c squared.
Yeah. All right, so we got to do that out. Okay, so 321 squared plus 150 squared. So you get 125,541.
Square root.
And then you got to add them up, which I just did, and take the square root. Okay, did I already add them up? No, I messed up. 321 squared plus 150 squared. And then take the square root. Okay, so the slant height is about 354.3. Now, that's the height of one of the sides. This dotted line I have in black, that's the slant height. It's going up the side of the pyramid. Okay. Now, this is going to become my height, okay, of one of the lateral faces. This is my base. Okay, so we fill in the base, fill in the height, multiply by a half. So the area is going to be 1/2 300 times 354.3. That's it. So we'll just do that up. Okay, so half of 300 is 150 times 354.3. So it's 53,145. Okay, remember, anytime you're writing an area, make sure you put the right label. Square feet, square inches, whatever it happens to be. This was feet. Any question on that? So now if you can find the area of one lateral face, you can find the area of all four. Just quadruple that. Then you'd have all the lateral faces. And then if you wanted the base as well, it's 300 times 300. It's a square. Area of the square is length times width. Okay, so you could do it that way. You could find the area of a pyramid just by doing each face separate, or maybe we can come up with a faster way. Okay, any questions on that? Okay, what would it look like if you unfolded a pyramid?
4 triangles and a square.
4 triangles and a square, so those would be the sides. Where would the square be if you unfolded it?
In the center.
Yeah, it would be right in the middle.
Well, there's many ways to do it.
Okay, so if you had a pyramid, you could have that part would be in the middle, and then you could have 4 triangles, not necessarily equilateral. They could be isosceles. So it could be something like something like that. A little smaller. Okay. And you'd have one of those on each side. Right, so I'd have to clone it.
You have to have them on each side, or do you have like right next to each other.
Illuminati.
Yep, you'd have to have one on each side, so then when you fold them up, they all connect.
Well, couldn't you just have that one connect to the other triangle?
Oh, you mean if you cut it differently?
Yeah.
Yeah, you could cut the pyramid apart differently. I cut it so that the base edge stayed intact, but I guess if you cut it so that the lateral edge was intact, you might have something like that. And then when you fold it up, you'd have to fold this edge up and then fold that edge over. I think that would work. Sometimes it gets hard to visualize, but the common way to visualize it as a net is just to have the square in the middle with 4 triangles on each side. There's definitely other ways to do it. All right. Okay, so this is going to be our shortcut to finding the surface area, total surface area of a regular pyramid. First, you need the area of the base. Okay, that's what B is. Okay, take that area. Then you're going to add the surface area of the 4 lateral sides. And that part is right at the end. It's 1/2 the perimeter times the slant height. We could go through why this is the formula in the explanation. Not as concerned with that right now. All right. So the surface area of a pyramid, take the area of the base, plus 1/2 the perimeter times the slant height. And that'll work for any regular pyramid. Only thing you need to be able to figure out is the area of a base. Okay? So if the base is a shape you're not familiar with, you might have to look that up. If it's like a hexagon or an octagon, and you don't remember the formula for the area of an octagon, there is a formula. Just look it up. You can find it. Okay, once you know a little bit of trigonometry, you might be able to figure something like that out without looking it up. All right, if you could make some triangles out of this, okay, maybe you could figure out the area of one of those triangles. Okay, and then, well, I don't think they'd all be the same here, but 2 of them looks like they'd be the same, and one of them might be different. But for us, the easiest thing is we'll just look up the formula and use that. Okay, what kind of pyramid is that?
Hexagon.
Yeah, you got 6 sides as the base. Okay, so that's a hexagonal pyramid. Okay, what makes it a pyramid? It all meets at a point. What makes it hexagonal? The base is a hexagon. Okay. So how many total sides do we have here? 6. Well, 6 lateral sides.
7.
And 7 with the base. So we could, if you wanted, you forgot the formula, find the area of one of the triangular sides, multiply by 6. That would give you all the lateral surface area. But then you need to know the area of that base. I still think we're going to have to figure that out anyway. Okay, so we might have to go back and look at our notes from last section, because I think I gave you the formula for a hexagon there. Okay, let's just start out with our general formula. How do you find the surface area of a regular pyramid?
Area of the base.
Yep, area of the base.
Plus 1/2 slant height. So perimeter times slant.
Yep.
I was getting there.
Oh, you weren't.
All right, so slant height, that's easy. That's given. Okay, perimeter, well, we can easily find that. One side is 6. We have 6 sides. 6 times 6, 36. So we got the perimeter. It's the area of the base that's going to be a little tricky if we don't know the formula. Okay. So let's go back at 12.2. Let's see if we have the formula for area of a hexagon. So this was all cylinders. Okay, that's for an isosceles triangle. Right here. Area of a regular hexagon. 3s squared times the square root of 3, divide by 2. So let's just write that down. 3s squared, square root of 3, over 2. Okay, it's the area of a regular hexagon. Okay, to me, that's the only part of this problem that's tough. You got to know that formula. Okay, I'd let you use a reference sheet on a test with that, or on the final, but I would not give that to you on a test or on the final. Okay? If it was a shape of a base I'd never talked about before, like a pentagon, I haven't given you that formula, and if I gave that to you on the test for the first time, I would give you the formula for how you find the area of a pentagon. Okay, so if it's a shape you've never seen, I'll give it to you, but if we've seen it, you need to write it down. Okay, so let's fill in. Okay, area of my base. Okay, S stands for the length of a side. Okay. How long is each side in my base?
8 or 6.
6. Right, so we're going to have 3 times 6 squared times the square root of 3, divided by 2. All that is just the area of my base. Okay. Plus, what did we just say the perimeter was? Half the perimeter times the slant height. Okay, this is where you got to be careful. If they gave me the height, I'd be doing Pythagorean Theorem right now to find the slant height. But I don't have to because they gave me the slant height, 8. Just to make sure remember our order of operations. What's the first thing I do when I'm finding the area of the base? Which calculation do I do first? Yep, do your exponent first. 6 squared is 36 times 3, okay, times the square root of 3, and take all that and divide by 2. Why the square root of 3? Yeah, we didn't go through the proof. Okay. For this problem, we'd have to go through the proof why it's the square root of 3, but not something we're going to do. Right. So that's the area of the base, 93.5. Plus half of 36 is how much? 18. 18 times 8. 144. Okay, so we got 144 plus 93.5. Oops. So as long as you know the formulas, this really is super easy. Just plugging numbers into formulas. There's no proofs. There's nothing that's too hard about this kind of stuff. Okay, so it's 237.5. Make sure you put the right label, square meters. Okay, and that's the total surface area of that pyramid. Okay, any question on that? Before we go on to cones, keep in mind, in this formula, there's 1, 2, 3, 4 variables. All I have to do is give you 3 out of 4. In this case, I gave you what you needed to find the area of the base. I gave you the perimeter, or you could find it easily, and I gave you the slant height. And I had you find surface area. Okay, I could switch that up. I could give you the surface area, give you what you need to find some of the other variables, and say, all right, find the slant height. As long as you knew this, this, and that, you could solve for the slant height. Right? So you got to always be given 3 out of 4 of the variables. Okay, so cone. Okay, easiest way to think of a cone, like I said before, is it's a pyramid with a circle as a base. If you think of it that way, you can reuse all the same formulas we already know. Okay? Even this one. Whatever it was. Area of the base plus half the perimeter times the slant height. That will still work. Except once it's a cone, I can tell you what the area of the base is, because the base shape never changes in a cone. In a pyramid, it does. Not in a cone. Okay. The base shape is always a circle. Okay. Okay, so a cone is basically, it's not a polyhedron, okay, because the base is not a polygon. You have a cone, you have a circle as your base, and you have a vertex that's not in the same plane as the base. Basically what that means is the vertex has to be up above the base. If the vertex was right on the base, you'd have a circle. Okay, so the vertex has to be up above the base. Okay, that altitude, or the height, is the distance between the vertex and the base, okay, just like a pyramid. And it's measured perpendicular, straight down. Okay, if you have a cone that's not slanted, okay, it's not bent in a right cone, the height will come right down to the center of the base. If the cone is slanted, that won't happen. Okay, slant height would be the distance going up the side of the cone. Okay, I like to think of it that way. That's the easiest way to think of it. Slant height, distance going up the side. So if there were stairs on the cone, you're walking up the stairs, there's your slant height. Okay, so there's a picture of a cone. Okay, remember dotted lines are the ones you can't see. They're in the back or inside. Okay, so there's your height, straight down from the vertex to the middle of the base. Okay, what do you think this distance r is? We didn't have that in a pyramid. That's your radius. Okay. So that's another place that they can try to trick you in a problem. If you need the radius to find the surface area, maybe they'll give you the diameter instead. So remember how you change the diameter of the radius. Slant height, it's marked right here, distance up the side. Base is that circle on the bottom. And the lateral surface, that would be just the sides of the cone minus the base. Any questions on that? What do you think it's going to look like if you unfold a cone?
It's going to look like a triangle, but like this.
So you're going to have,
Like a piece of pizza with a circle on it.
yeah, so basically you're going to have like a piece of pizza. One edge is going to be curved. The other two edges are going to be straight. That would give you the sides. But then you're also going to have a circle, okay, somewhere else. So actually, this is more than like a piece of pizza. It almost looks like almost a whole pizza with a piece missing. So here's your two sides. Okay, this circular part right here, that would be your base. Okay? Radius is marked as L. Okay? The distance going around the edge here, that would be the circumference. Okay? If you were to wrap that back together, this part would make a circle. They'd be touching. Okay, so that would be 2 pi r. And then the distance from here to here, that's your slant height. Okay. Think about bringing those pieces back together. That would be on the base. That would be all the way up at the top of the cone. So this shape that we have here, this is called a sector. Okay. When you take trig, if you take trig, you talk more about that. Okay, so a sector is basically any part of a circle. You got the two edges that are straight, and you got this curved edge. Okay, so a sector is a part of a circle. Well, the base, that's easy to find the area of. We already have a formula to find the area of a circle. We don't have a formula to find the area of a sector. First of all, is a sector even a polygon?
No.
No. It's got a curved edge. Okay, curved edges aren't polygons. Right? But we can use that proportion to find the area of a sector. Okay, in trig, we actually go through, we derive the formula on how you find the area of a sector based on using what's called radians. Okay, how big of an angle that you have inside here. We're not really going to get into talking about the angle that's inside there in this class. All right, so we're not really going to focus though on finding just the area of a sector. We're going to find the surface area of the entire cone, and I'm going to give you a formula to do that. Okay, it's basically going to be the formula you just had. It's the area of the base plus pi RL. Okay, so pi, anytime you use that, you can always round to 3.14. Okay, R is your radius. Notice it's used in a couple spots. And L is your slant height. Any question on that formula? Okay, so I think I said on the last part that the formula was identical. Well, you don't see that 1/2 at the end. The other one I had, it was area of the base plus half the perimeter times the slant height. Well, the 1/2's not there. But my question is that really still is the same thing. Can you explain how that formula would come from this? Okay, that's kind of the generic formula. What's the area of a circle? Start with that.
Pi r squared.
Yeah, that part, there's your pi r squared. So pi r squared. But where does the 1/2 go? I'm still claiming that this formula is correct, even though you don't see the 1/2.
Well, wouldn't it be like you're taking 1/2 of like an entire full cube, right? So if it was a cube, and you're technically cutting it in half, because it was like a triangle, you're cutting it in half, so you take it up.
But how come we don't have, why don't we write the 1/2 then? Where did it go?
Because they didn't feel like it.
You didn't feel like it? Well, what's the perimeter, well, or circumference? What's the formula for the circumference of a circle?
2 pi r.
There you go. 2 pi r. What happens when you multiply 2 and 1/2 together? You get 1. So all you're left with is pi r squared plus pi rl. So the 1/2 is there. It's just it cancels out with the 2 from the circumference of a circle. Okay? So you can still use this formula if you want to. It's just those two things, the 1/2 and the 2, cross out. Become 1. Okay. Any question on that? All right, so it's up to you. As we go through these formulas, you decide, do you want to try to remember just the general formula? And then on a separate piece of paper, write down areas of bases and circumference? Or do you want to try to remember every specific little formula for every shape? I think the general formula is easier to remember. Then you only have one formula to remember for cones and pyramids. It's the same formula. But it's up to you. Whatever is easier. Okay, so surface area. Again, I don't think of it specific. I think of the general. It's going to be the area of the base plus half the perimeter times the slant height. Okay, so my base here is a circle. Rose, what's the area of a circle again? Anyone help her out? What's... Oh, Connor, what's the area of a circle?
Pi r squared.
Yep, pi r squared. pi r squared plus half the perimeter. Okay, Luke just told us the perimeter is 2 pi r. 2 pi r. Last thing I need is the slant height. This time they gave it to me. What if they had given me the height? What would I have to do first?
Pythagorean Theorem.
Yep. If they gave me the height, I'd do Pythagorean Theorem to get the slant height. Okay, if we leave this first part in terms of pi, Ariel, what do you get?
16 pi.
Yeah, you just get 16 pi. Okay, so if you want to leave it in terms of pi, that's fine. If you want to round it to a decimal at the end, we can do that too. Okay, how about the second part? I get 16 pi plus, Sarah? You're multiplying those three things together, but you can do it in any order you want. And you don't need to use 3.14. Just keep it as pi.
Pi 24 or 24.
Yeah, let's write it as 24 pi. Good. So we get 16 pi plus 24 pi, which is, Olivia, how much?
40.
Yeah, 40 pi. Okay, remember what they were asking you to find. Area. So that's 40 pi square inches. Okay. If they wanted it as a decimal at the last step, I would now just type in 40 times pi. Okay, I'd rather you use the pi button on your calculator. I know on MCAS they say to use 3.14. But for the tests in here, just stick with the pi button. Okay. It's about 125.66. Exact, and then approximate. Okay, any question on that one? Okay, so this is the surface area of a cone. We'll do one more. This will be the last one. Okay, this time, we're going to solve for two things. We're going to find x, and we're going to find y. Okay, they've told us here that the surface area is 76. Okay, let's start by writing down our formula, and then we'll fill in. Okay, who can give me the formula for the surface area of a cone? Give me the specific one, not the area of the base plus half the perimeter. Just give me the times the slant height. Give me the regular, fill everything in. Yep.
I r squared plus I r times slant height.
Yep. Good. Okay, so 76. Oops. 76. That's going to be my surface area. Okay, fill that in. Okay, pi. For now, we can leave it as pi. Eventually, if we're going to solve it, we have to round it off. I'll leave it as pi in this step. Okay, what's my radius? Yeah? 3. Okay. So my radius is 3 plus pi times my radius times my slant height. So there's only one thing I don't know in that whole equation. Slant height. Okay, let's do it out. Okay, I am going to round this off now. 3 squared is 9. Make sure you do that first. 9 times pi. All right, so 9 times pi, you get 28.27. Plus 3 times pi. 3 times pi. It's 9.42. Okay, so now my goal, I got to get L by itself. Okay, from here, just algebra 1. Okay, Justin, what would be my next step to get L by itself?
Subtract 9.42.
Can't subtract it. We got to divide by it, but not yet, because it's multiplied by a letter. We can subtract something else.
28.27.
Yep, we're going to subtract 28.27 from each side. So we get 47.73. Now we can move that 9.42 to the other side by dividing. Okay, so my slant height is about 5.07. Okay, go back up, see what our label should be. What should my label be on that? 5.07 inches. Why not inches squared? That's not an area. That's a slant height. That's a length. Okay, it's one-dimensional. Okay, so 5.07 inches. But let's see. Did we find everything they wanted? We found the slant height. So that's really, this is y. Okay, they called it y in our problem. How are we going to get x? Yeah, we're going to use the Pythagorean Theorem. What is x really called in this cone? Y was the slant height. X is the
Lateral height. No,
just the height. Yeah, just the height. Okay. So, and someone just said we're going to use the Pythagorean Theorem. Okay, who can fill in the numbers that we're going to need for that and put them in the right spots? Okay, be careful which ones you put where. Yeah.
A squared.
Which one?
A squared plus 3 squared equals.
Oh, you know, I'm going to use x, just because I'll use x here. Yeah.
X squared plus 3 squared
Good.
equals 5.07.
Okay, this is a mistake that a lot of people make. They'll put the numbers in the wrong spot. 5.07, that's not a leg. That's a hypotenuse. Okay? So it's always one leg squared plus the other leg squared equals a hypotenuse squared. That's perfect. Yep. Thank you. All right, so we do that out. Okay, x squared plus 9. 5.07 squared is just a little bigger than 25. So 25.70. Okay, I've just been rounding to 2 decimal places in this whole problem. Okay, so 25.70 minus 9, 16.70. And what's my last step to get rid of that exponent? Yeah. Yep, take your square root. Okay, it would have been nice if this came out to exactly 16, and the square root would have been 4. So it's going to be a little bigger than 4, 4.09. And again, don't put inches squared. That's not an area. That's a height. That's your height. That's your slant height. Okay, does anybody know what that's called if you had this triangle and the base was 3, and let's say x came out to exactly 4, and then the slant height would have come out to exactly 5. This would have been 3, x would have been 4, y would have been 5. There's a name for that. Nope, good guess. Anybody know what that's called when all the sides come out to nice numbers, no decimals? It's a question on your final. So that's why we got to go over it. Anybody know?
Perfect.
It's called a Pythagorean Triple.
What?
Okay? If you have all the sides in a right triangle and they come out like 3, 4, 5, they come out nice, it's a Pythagorean Triple. You can't pick any numbers and have it work. They got to be special. Another one is 5, 12, 13. So like if you check this on your calculator, if that's a leg and a hypotenuse, that works. 5, 12, and 13. Okay, that's called the Pythagorean Triple. If the numbers come out to decimals, then it's not a Pythagorean Triple. Okay, but that'll be one of the last things we study next academic week. Okay. Okay, any questions on that last problem? All right. So I'm going to give you guys a little bit of time to start the homework. Okay, it's on 7:38. Okay, 15 to 24, I'd like you to try all. 26, 29 to 35, just the odds on those. And 41.